Welcome to Community Update 183. The networks, by and large, are running the same versions as before. On the DevNet, they're doing newer versions and testing them out. But other than that, from what is visible to the public on the testnet and on the mainnets, things remain the same. The focus for the past week has been, as well as this next couple of weeks would be, the next few weeks would be block merge, hard fork 2. Specifically, where the team is working on the per deploy vault solution, attestation messages, and then doing a lot of testing and bug fixing and also performance improvements. So I want to speak to the testing and bug fixing part first. NutZipper has made significant progress on the testing of the block merge. He has created a simulator, a DAG simulator, so that we can quickly run the whole block merge process through a variety of DAG configurations, whatever may show up in the simulation. This way you are able to, so he basically specifies the number of nodes, and then the simulator simulates the network traffic and going through the whole process of block merge. And this enables quicker testing and quicker discovery of problems and a larger test coverage. So that's what he's doing. And of course, he has to make it work in the different scenarios. Meaning, make sure that whatever the node is doing, it doesn't conflict with this methodology. But in the medium term, this has potential to actually potential to be expanded more, so that we can use it for full network simulation, including block generation and things like that, as well as identification of any security holes, those kinds of things. So it's a longer term tool. We just have the beginnings of that at this point in time. So I wanted to point that out. And maybe next week or the week after, NutZipper will probably do a presentation on that, and perhaps with Thomas Lau expanding on that with the vision of how we intend to use it over the next several months, basically. So that's with testing, but so the block merge code is complete, but there is testing and there are bugs being discovered and fixed. That's where we are on that. The per deploy vault work is proceeding, and Will is going to start work on the attestation messages this week. Basically, the attestation messages allow finalization to continue and complete, whether or not there are paid deploys that are following on after a particular block. So this allows us to do finalization without having to overbuild the network or do a whole lot of dummy block generation and then the dummy block replay by all the nodes and networks and all of that. So that's kind of the advantage of the attestation messages. That's the role they play. That's the reason why we're doing that. So that work will start, so that'll be worked on over the next several days. Then Dennis is making performance improvements on the Merkle tree. Basically, the activity here is to take the learnings from the engagement we did with hardware acceleration, and then now mimic them in the software, initially in Scala and potentially in Rust as the next go round. So that's the activity here, and he started working on that. One other thing that was going on, Steve Ross Talbot had presented in the Discord channels the power consumption advantage of RChain. And what he's done there is just to keep the comparison simple, because he was working off of a Tejo's case study of what they were showing. He was comparing it to 52 transactions per second. But there was a request from the community to say, hey, like, can we actually use the real transaction numbers from the RChain network so that the use case looks even better than what it is, how it is currently presented, I should say. So the reality is it may be potentially better than what the presentation is at the moment. So to validate that, we will be generating some real TPS numbers over the next week or two, so that we can then update the power consumption data correspondingly in that spreadsheet that Steve has done. The other thing, there was a bug reported, this issue 3491, which was that the full data set was not being used for hashing in the current code, and that is now fixed. And then Will has completed that. There is still he's just completed the code for that, so there's a little bit of testing to complete on there and getting it for review. But that will also be going in the current release. On the testnet, I think over the weekend there was an IBM node disk failure, and that kind of and this was only on the testnet. In general, when we have the leaderless and 0.67 synchrony constraint mainnet, this one particular node failing should not really make a difference, because the network would seek the 0.67 synchrony constraint from the rest of the stake that is available from the rest of the network that is live, and things should move on. But it does give us a data point to say, well, what is it that we could do here and what needs to be done, because there is a potential that many nodes may say simultaneously have a disk failure, right? So, or a network failure. So we will investigate that, and the current thinking is that basically we should be able to switch them to read-only mode, or use the read-only data, and then when the disk or network is back, we should be able to switch them back to validator mode relatively easily. But this is something that we will investigate. We don't have a completely thought out process yet for that, but we will be working towards that. So that's on the SRE side, one of the new insights and new tasks that we're taking on. And I want to give out a community contribution shout out. Toby has created a very nice Rolang SDK. The link is in here with, and he used a NFT template application as an example for his SDK. So this SDK basically lets a newbie to the project set up the whole environment quickly and have the ability to work with the local or the testnet or the mainnet as needed. And then he has this NFT application. So I think that's, I'll actually just share that screen briefly. This is how that looks. I think you're still able to see my screen. So I encourage people to try this out, give him any feedback you have. But from what I've seen of this, it looks very nice so far. So now it looks like we at least have 3 different ways or times we demonstrated NFT generation on the network. Toby's method is one. Dappy has, Raphael has generated and demonstrated that on the Dappy platform before, and the R publishing team is also developing their methodology there. So that's just the application here, the NFT template. But in general, the toolkit, the SDK, I think is useful just to quickly get on board with the with RChain dApp development. So I encourage people to take a look at this. That, I think, is all I wanted to cover. Are there any questions, comments from anybody?
This is the first I've heard of the rolling SDK. That's quite cool. Very exciting.
Yeah, I also heard about that only this morning, and thank you, Tomislav, for pointing that out. So Toby has been quietly working at it and has I guess done a quiet release of that. So
yeah, no, this is awesome. Really good. That's great. Yeah. Cool.
Oh, I forgot to mention about the work going on in the hard fork 3. Quantifier is continuing to work on system contracts update, also otherwise known as the soft fork process. That's continuing, and then the rev vault logging is ready for review and is being reviewed. So that's where we are. But that's hard fork 3. So in terms of actually seeing it on the main net or test net, that'll be a little while. But he's making progress on that. So
that's great. Good news.
Yeah. Anything else from anyone? Otherwise, it's over to you, Greg.
Thank you. There is some updates about rolling I'd like to talk about, but I'll do that after Daryl does the week in review. Daryl, are you here? Are you ready?
I am here.
Awesome.
All right, so here's the week in review for July 29th to August 4th. On Thursday at the Governance Committee, we discussed a doc that Rao is preparing for the board to consider regarding business model, revenue streams, token economics, and network security. Let's see, also on Thursday, the App Developer Working Group developed message queue implementation for database replication across RChain. On Friday, Climate Coordination RCast, we discussed severe flooding in London, the rehabilitation of a river in Boston, and Eunice Foote, a scientist from 1865 who first discovered that CO2 warmed the atmosphere. Steve Ross Talbot also shared his blockchain energy consumption research relating to RChain, and we had a discussion about the value of NFT versus the actual art. On Saturday, in the RGov Smart Contract Call, we worked on MetaMask integration for new ballot interface. Oh, Greg, I didn't get a chance to get your Casper Standup summary from Monday.
Oh, I sent it out. That's okay. I'll cover it right after you're done.
Okay, cool. Let's see. Also on Monday, the RDOV member co-op planning, onboarded cooperation at scale researcher Jorg Blumtritt from New York University, LMU. Connection through RChain member Doug Rushkoff. On Tuesday at the Communications Working Group, we discussed messaging around our impressive staking numbers, how to greater improve the communications between the Chinese community and the RChain community outside of China. And Theo proposed using an open source tool called Node-RED to do some tweet automation. And then this morning in the active member hangout, Raphael did a demo of DAPI's RChain token structure and interface. We also talked about getting guests like Daniel Schmachtenberger on the call, who Jim has connected with. And then we talked about mixed reality and Zuckerberg's world domination vision, who sees mixed reality as the next computer platform. And then that brings us to now.
Thank you. Any questions or comments for Daryl? All right. So in the Casper stand-up, what I talked about was geometric algebra, and in particular looking at it like a data type that could be incorporated into a programming language. So probably many of you on this call, and certainly many people who would be looking at this later who are technologically inclined, understand that linear algebra is a widely used tool for doing everything from physics to computer graphics to all kinds of analysis in the sciences and finance. it turns out that there's a generalization of linear algebra called Clifford algebra, and when it's specialized to geometric applications, it's sometimes called geometric algebra. But those two terms effectively refer to the same body of mathematics. And this has a remarkably improved expressive power over linear algebra in many respects. I have talked about it in this venue and the Casper venue and others many, many, many times. If you go on YouTube and you just type in Clifford algebra or geometric algebra, you see it as a cottage industry to produce videos about geometric algebra or Clifford algebra. There are, I would say, at least as many videos about geometric algebra as there are about blockchain. So that would give you a sense of its popularity and the level of excitement in the scientific and computing communities. In particular, the graphics community is very excited about geometric algebra as a way to provide a much higher degree of compression and efficiency when expressing geometric operations. And so the thought is that as Erlang begins to grow up and become a full general purpose programming language, it needs libraries and data types that expand its applicability, and in particular, especially, expand its applicability into graphics and the sciences, such as physics and fintech. And so geometric algebra is a very, very good example of the kind of data type that we would like to add to Erlang over time. And so the Casper stand-up, if you get a chance to watch it, kind of goes over some of the basics of Clifford algebra. Again, I heartily recommend, if you are interested in this topic, there are many, many good resources. David Hastinus's book is quite good, and Doran and Lazenby's book is quite good. So I mean, don't just rely on the little example that I put in the Casper stand-up, because I was driving towards other things. So all of that is just goodness. It's just the natural kind of goodness that you would expect, right? I mean, one could easily see adding Clifford algebra as a built-in data type to Scala or Java or Haskell or C++, and in fact, there are many, many Clifford algebra libraries already in languages like that. So it's a natural thing. It's a natural sort of engineering evolution for the growth of Erlang. However, in keeping with the spirit of the Casper stand-ups and the research side of it, one of the things that I pointed out is that using the geometric information, one can imagine a second order evolution of the COM rule itself. And so right now, there's one and only one COM rule in Erlang. But as we add enriched data types, and the values of those data types are incorporated into Erlang as processes, then they can become, through the at operation, through the address operation, they can become names in their own right, and thus be either end of a channel. And so when you have a highly structured data type, a value in a highly structured data type, you can introduce what it means for two values to be either end of a channel. So in the case of Clifford algebras, one example is that the two vectors or or in vectors are orthogonal to each other. So their dot product is equal to 0. And that would allow for the expression of a kind of dynamics that is new, both to the process algebra side, but also in the modeling of dynamics in the scientific side, the mathematical and scientific side. So as I've said many, many times, but it's bears repeating until it's understood. When expressing dynamical laws in physics, as an example, entities like vectors are static. They are not dynamic. They represent state as opposed to state transition. And transformations, such as linear transformations or other kinds of transformations, represent the dynamics. In the setting that I'm proposing, we have a new kind of dynamical law, which is a rewrite rule, which is no longer a linear transformation. In fact, it doesn't even have to be a function. But it does fit well within the rubric of computation. So it's well understood, and it can be typed and subject to by simulation and a whole bunch of other wonderful mathematical tools and techniques. And so this represents a shift, a change in how we might think about dynamics, both on the computer science side, but also on the scientific side. So that's what makes it interesting from a research perspective. So again, just to recap, Clifford algebras are already good. They have found applications all over the place, from navigating drones to applications in finance and other things. So incorporating the Clifford algebras into any programming language is a good idea, and hence incorporating them into Rolang is a good idea. Once they are incorporated into Rolang, there are some interesting possibilities that arise as related to the expression of dynamical laws. And so it impacts both the notion of computation, but also how computation relates to modeling of physical processes. So a little bit of brain candy for today's community debrief. Any questions or comments?
Quantum logic, can you hear me?
I can, yes, Jim, yes.
I guess the work with quantum logic, I guess Obama and others, was dealt with complex Clifford algebras. Is that the same thing that you're talking about?
It's the short answer is yes. There's a longer, more technical answer, but the short answer is yes. Clifford algebras already have a notion of complex.
I would think so.
Clifford algebras generalize the normed division algebras. So there are only 4 normed division algebras. Isn't that interesting, right? So there's the real numbers, there's the complex numbers, there's the quaternions, and there's the octonions, and that's it. That's all there are. There are no others. What is really interesting, and again, it's an art is long, life is short. Standard probability theory is expressed in terms of the first one, the reals. You can view, and Scott Aronson has many enlightening articles about this, you can view quantum mechanics as essentially, if you just simply forget about its physical interpretation, quantum mechanics with the Born rule is a way to interpret the complex numbers as a theory of probability. And so what nobody has done, to the best of my knowledge, is to propose a theory of probability that uses the octonians, or a theory of probability that uses the quaternions, or one that uses the octonians. So that's that sort of begins to give you a little bit of context. My view is that I would rather have quantum logic show up as the output of OSLF when run on one of those normed division algebras. So that's so rather than have a by hand like handcrafted logic, as is the von Neumann quantum logic, instead have the logic just pop out because one has applied OSLF to one of the normed division algebras, such as the complex numbers. So that's some context. And then, of course, you can apply OSLF, and this is something I've been hinting at for quite some time. You can apply OSLF to the Clifford algebras as well. So in particular, when we apply OSLF to Rolang and get a type system, if at that point Rolang is already enriched with the Clifford algebra data type, we will automatically get a type system that includes typing Clifford algebra values. And this will give us the ability, for example, to explore at the type level rotations. So you can check at the type level if a given Clifford algebra value is a rotation or a blade or any of these other sort of common and useful notions that arise in Clifford algebras. So you can see them as subtypes of the Clifford algebra value type. So hopefully that provides a little bit more color and context to your question, Jim.
Al, thank you very much. I hate to ask more questions, but how does that relate with Lie algebras?
With Lie algebras?
Lie algebras.
That's a whole other can of worms. So I'll take that. I'll take that offline. But I mean, there is a connection. The problem is that by the time you get to Lie algebras, you're definitely dealing with the continuum. So at that point, you have some hard questions to answer about computability.
Yeah. Okay. Yeah, that answers my question.
Yeah, sure.
Greg,
good. Yeah, go ahead.
Greg,
I was about to call on you, but go ahead.
Well, I found one of the references you mentioned, David Hestenes.
That's right.
I put it in the chat, tutorial on geometric calculus, but you mentioned another reference as well.
Yeah, Doran and Lazenby, they have a book called Geometric Algebra. They're Cambridge professors, yeah, or at least one of them is. And yeah, I'm pretty sure it's Doran, because Doran's wife also works in geometric algebras, and she has an interesting YouTube video. Yeah, and in 2020, I think Games 2020, they released, so that conference released a lot of videos of talks, and a huge percentage of those talks were on Clifford algebras or geometric algebra. So,
very good.
Yeah.
Great, thank you.
Sure, yeah, please put it on your radar. It's very important, especially for those people who are interested in computer graphics. It's extremely important. Hint, hint. Okay, so over to you, Steve. I think we had talked about you giving just a brief overview of the Government Blockchain Association and our relationship to it.
Yeah, be happy to. Hi, everyone. So I recently became a member or joined the Government Blockchain Association, or also referred to as the GBA. And the GBA, you can kind of think of it as a mix, individuals who are, they're government employees, federal, state, and local, individuals from academia, university professors, and then individuals from industry, such as myself. And they have various workshops, transportation, grant writing, and about 50 different working groups, I should say. And one working group is called the Investor and Startup Community Working Group, which recently met. And they actually presented an opportunity, a fundraising opportunity for us, which is so one member of the GBA is also belongs to the World Business Angel Investment Forum, and she hosted the meeting earlier this week. So essentially, it's an opportunity to present to the World Business Angel Investment Forum on the global fundraising stage. So it's essentially for 20 startups, and they can be in the startup stage or in the scale-up stage. And they'll be presenting to angel investors, family office executives, fund managers, VCs, and the like. So this would be an opportunity for RChain, Dazzle, and potentially RChain Publishing to put together a pitch deck and present to, I believe there's going to be about 75 angel investors that would the group of 20 startups would be pitching to. And with the two categories, so the first category of startups, they can be funding anywhere from 50K euros to 500K euros. And then for the scale up category, it's 500K euros to 3 million euros. And it's the application time just opened up August 1st, and it closes August 9th. So it's a short window. So we're working to get all of that coordinated. It's a 3-minute pitch, so it's very quick, and each presentation will have 3 to 5 slides. But once the presentation is done, then individual angel investors will speak to the presenters to do a further due diligence. So yeah, that's the opportunity, and the GBA is turning out to be a wealth of information and resources. So I'm each week I'm finding new things, new opportunities being presented. So it's been a worthwhile membership. So any questions? If any, happy to answer any questions if anyone has questions. Great, thank you.
Thanks, Steve. Thanks, Steve. Yeah, I'm excited about this. I think it's a significant opportunity, represents a significant opportunity for the cooperative.
Yes.
There are other things to discuss in the, but that would be for the closed door session. Some nice developments. So if you have the time and the inclination, please join us on the Friday call as well. Any questions or comments from the community at this time? All right. Thanks to all for joining. Please stay safe, stay cool, and see you on the other side.